Okay, let's come to the part 3. In this part 3, we're going to see how to configure OSPF, the OSPF protocols. So the OSPF protocol needs you to have the followings. It needs you to have the route IDs for the OSPF to identify uniquely the routers in the OSPF domains. It also needs you to have the area. So if you don't have multiple areas, you are recommended to use area 0, which is backbone areas. Also, we need to have also the the network that we are going to advertise. For the interconnections, what you should do is to advertise only the point-to-point networks to the OSPF domains. So when you advertise this, the point-to-point network, what does OSPF do? The OSPF will start to converge and to calculate the shortest path routes to the destinations based on the RSAs or the packets, the RSAs packets that is receiving from the peers. So you see how the OSPF form adjacents and they start to from the full neighborship and they start to exchange the LSA packets. When it's boot on and it's configured with OSPF, it will start by identifying neighbors. So example for the Dodoma routers, it will identify neighbors by sending hello packets to the multicast with the multicast IDs to all other routers in the OSPF. So when the router is running OSPF and it receive the hello packets, it will just reply by another packet with its own route ID. So the Dodoma router, it will receive the router, the hello packet, the reply hello packets from Paris with the route ID 00222. The same applies to Nairobi, which is route ID 4555. So Dodoma, we're going to have 2 neighbors. So its own. Then after that, it will just proceed the next step by just exchanging the database description packet, which is called the DD. You see the first packet, it's hello packet. The hello packet is for neighbor and neighbor discovery and the neighborship maintain. So that's how hello packets used. The second packet will be database descriptions. It is called database descriptions. So in the database descriptions, it will be shared to all other neighbors, to all neighbors. This it will tells, because in the database descriptions here we have the RSAs, advertisement packets. So it carries the basic information, the example cost of the interface, status of the interface, and some cool stuff that is used by the OSPF to during the routing calculations with the protocol with SPF, the shortest path first algorithm. So this will be carried on the DD packets. So after that, if the Dodoma router received the database descriptions from the Nairobi and it found that on the database descriptions there is some routes or there is some information which is missed from that, the Dodoma router will now send the RSA packet called the second packet, the third packet, which is called the link state request packet. The link state request packet, this will be sent to the router, to the Nairobi router, for requesting that I don't have the routes that you shared on the DD packets. So I'm requesting that packet. I'm requesting those informations. After Nairobi received the request packets from Dodoma, it will reply with the packet called link state updates. In the link state updates packet here, you see the router, the Dodoma Nairobi router is now updating Dodoma router with the updates from the database descriptions that was sent from Nairobi to Dodoma. After that, the last packet will be sent from Dodoma to Nairobi for acknowledging what was received or what was sent by Nairobi to Dodoma. These are the 5 very important packets that are exchanged during the OSPF negotiations. You have to understand how this, I've just explained the basics, but there is a lot to learn. There is a lot to explore. You can just go and Google some information of OSPF and learn about these packets. They're very important. You have to understand that each router will need to have adjacents to the other. So the adjacents peer or the adjacent router is the one that they have fully exchange the packets, the full exchange, the basic the information, example database descriptions, and some other packets. That's where the two routers are said to be peers, because they're in the full adjacent relations. So, but not all routers in OSPF, they can be adjacent, but only those which can which they have exchanged the database descriptions and the other LSA packets, they form the LSAs. But for the, according to OSPF has four networks. For network type, there is point to point, there is point to multi-point, okay, to multi-point. There is broadcast network, and there is the non-broadcast multiple access network. So in this four type of the network, there is this called election of the DLR for the two types of network. Designated router and the backup designated routers. This is to remove. This is to reduce the number of adjacents. Example: if two routers, if two OSPF routers needs to exchange these 5 LSAs packets, they need to be in the full adjacent mode. They need to be full adjacents. So example, if you have 1,000 routers in your network, you can't exchange the LSAs packet to all of 5 routers, because you're gonna run out of the resources, the CPUs and the memories, because some of the routers they don't have the capacity. Some of the routers they don't have enough storage, so you're gonna run out of the resources. So the good way is to maintain and to manage this RSA's packets. So only DLR and the BDR will be able to establish adjacent with others. For the broadcast network, and I think non-broadcast multiple access networks, here we have the selection of DLRs for us to reduce the number of adjacents that will be formed by the routers. So example here, for if London is a DLR, only London will establish adjacents with all other routers in the networks. So because we have DLR, we need to have a backup DLR in case the DLR goes off, so the BDR will take over the roles. And after that, the selection of BDR will start again. How the DLR and the BDR is erected? We have the principles here. Because first we have the priorities of the router. The router itself that is running OSPF has its own priorities. So the router with the highest priorities is going to be is eligible of being selected as the DLR. If it's not having the highest priority, then it will not be involved even in the part of the DLR elections. Example, the highest priority is 255, which is the highest priority. If the router is configured with priority of 255, that is purely going to be the DLR in the network. But if it's going to be configured with 0, that is not qualified to be the DLR at all. So other routers with the normal with the default priority will be erected. So if there is also routers which are having equal priorities, then I think there is we are going to select the router which is having the router ID, the highest router ID in the network. That's how we select the DR and the BDR in the network. After that, the very important thing is, for me, for this lab, I'm going to say this network here, it has to be a point-to-point network, and this also here needs to be the point-to-point network. Point-to-point network. Also, this one here is supposed to be a point-to-point OSPF network, but others by default is broadcast. If it's a broadcast, that means they need to select DR and BDR. But for the point-to-point and point-to-points, we don't need to be we don't need to have a DR and a BDR, because it's a small network. It's a point-to-point. It's only 2 routers, so there is no need of having a DR. But for the broadcast network, we have multiple routers. We have millions of routers, and here we sure need to have a DR for the DR and a BDR for the routes. For the LSAs that advertise on the packet and the adjustment and the adjacents management. So let's go straight to how to configure OSPF. So I'll take one example as usual. I'll configure OSPF, and I'll show the rest how to configure to the other routers. So for now, I'm going to advertise only the point-to-point networks for me to achieve the reachability between the OSPF domains. Here, so let's open the DOMA routers. So and the DOMA router, go direct to the system view. In the system view, the first thing is to light the keyword OSPF, and then you select the process. The process can start from 1 to this number. It's a very big, so you can manage a lot of the OSPF. It depends to your with your router capabilities. But for if you didn't select any process, the one is the process ID 1. It's default by it's default. It's by default. It's 1. But the very cool, the very important things here is to assign IP the route ID. As I said, if you need to configure router ID in the protocol view, that means this one will be preferred the most compared to the one that we have configured it. Example, you can say display router ID. You see, this is a router ID of the router, but I need also to configure the router ID on the OSPF when I'm creating other OSPF. The also process ID, it's local. You see here, it's 1 by default, but this one has a local significance. It doesn't mean the process it should be ISO should be the same all over the network. No, it has the local significance for us to identify or to separate the number of processes that we can configure in the router. What should be what's supposed to be equal or should supposed to be uniform throughout the network is the area where you have located the routers. So the routers that are running in the same area, they are possibly going to form adjacent to each other because they're exchanging the LSAs for the router calculations and some stuffs. So that's a very important things. The area is a logical corrections of the routers. It doesn't mean that if I'm saying OSPF area 0, the routers should be in the same geographical region. No, it's not that way. That's a logical. It's a logical area. It could be the router could be in the different geographical region. As you can see here, we have a router in Paris, router in Moscow, router in Dodoma in Tanzania, Nairobi in Kenya, London in England, and some stuff. So this is a logical area. So, but the router that are running in the same OSPF process, I mean that you need to be in the same area. You should first consider that. So the area, how many area you can create? You can create around the 4.2 billion areas. So for me, I'll just configure area 0 because this is the backbone area, which is by default. So this is how you enter in the area view of the of the OSPF. Then in the area view, what you need is to advertise these networks that are going to run OSPF. So you see for the Dodoma, here we have 192, 160, 160, 50, 20 /30. So what I'm going direct, I'm assigning the network, which is 192, 160. They're gonna be 50, 20, and 24. These are the two networks in the Dodoma router. It's 20, 30. Okay, now it's not subnet mask, it's WD mask. If you don't know this, you can go direct and check what does the WD mask means, but this is how it's calculated. It's a negative of the subnet mask. You see here in the subnet mask we have 31s, which representing networks, and the 2 bits which are 0 representing host. But for the WD mask, you need to flip the zeros to ones and 1 to zeros and convert it to decimal. That's where we come out with 3. So now that's cool. Go to the second network, which is .4. You see now we have this network here. Okay, that's cool. But also one more thing, I want to show you how you can configure cost based on the the bandwidth reference. Cost can be configured, or cost can be calculated based on bandwidth reference, bandwidth reference divide by bandwidth, interface bandwidth. So we have this this way of, okay, we have this way. So there is this way. You see, by default, OSPF cost is 1. OSPF cost is 1 for all interfaces. But if you have interfaces with different capacity, example 1G, 100 Mbps, 10 Mbps, 100 Mbps, 50 Mbps. So you need to be more intelligent and enable router and tells router that you need to configure, if you need to calculate cost of the interface or cost of the link based on the capacity of the interface. That means if a port having higher cost, a higher bandwidth, that means the cost should be less. Example here, let's take an example. If you have the interface with 100 with 1000 GB per second, gigabit per second, then if I put if I put the bandwidth reference, I think this is the reference number that will be dividing with our bandwidth, interface bandwidth, to get the cost. If I put the interface, the reference bandwidth to 100,000, here I'm gonna get 100 cost. This will be the cost of the interface. But if I'm having an interface which is fast Ethernet, which is speed, it's approximately 100. I'm gonna have the cost of the interface 2000. So you see here, if the router calculates the route to the destinations, it will prefer a route with smaller cost. And if the route is a smaller cost, that means this is where I can forward my traffic. And in the reality, it's aware that we have a higher bandwidth compared to the one which is with persistent. So this is a good way of configuring your network by fixing the bandwidth, by fixing the reference bandwidth, and telling the router that you have to consider, you have to concentrate, or when you calculating your costs, make sure you are taking care of the bandwidth difference. So in the router here, if you need to configure bandwidth, you just need to go to the OSPF view. Then and after view is you just try to just write bandwidth difference. Then I'm gonna assign, I can say I'm gonna assign 100. It will be 100 gigabit per second. So this is the reference bandwidth. So the reference bandwidth, it has to be uniform throughout the network, because if you don't configure bandwidth reference here, then this router will calculate cost based on its own way. That means the default way. So if you need to all of your routers to configure cost based on the bandwidth reference, you need to configure this bandwidth reference through the entire network. That's how we configure here. So you see now, this is a very basic commands for us to configure. Then we don't have any. So let me copy this script. This is sample, and I go direct to the notepad. And yes, so this one should be a template. If it's a template, then we have four more routers to configure OSPF. So I'm gonna pause these videos, and I'll just show you two, and then I'm gonna pause the video and assign the list, the IP address. Let's go direct to Paris, which having the router ID, which is 2222, and the network which is there is 12.4 and 24. So I'm gonna add one more line here for the 12, 24, it's 4, 12, it's 4, 12, and the route ID is 2222. Now the reference boundary is the same. So go direct and say serve. Okay. Then after that, then cool. Copy the configurations, go direct to Palis router, which is here, the Palis router. Okay, go to the system view, paste the script. Now you see, if you display this current configurations, okay, if you say current configuration OSPF, you're gonna filter only the OSPF configuration at that time. You see now the configuration says we have this one here. Now it's cool. Let's go to Moscow, which is having 333 and its out ID and 12 also with 0 as network. Copy this script, go open the new pad. The route ID is 3333. 3333. The reference band is the same. The network is 0, and now we have 12. It's cool, yeah. 12. Yes, we don't have this one here. Let me remove it. Okay, go. Then after that, you can just display current configuration OSPF. Then hash copy configuration. Go to which it's Moscow, right? It's Moscow. Then into the system view, paste the script. Do you see now? Coca CC OSPF. Now you see. Also, we have already started to form the adjacents, the neighbor. You see, we have the neighbor already here. You can go straight and display the OSPF peer brief to see who is my neighbor. Now you see, now Moscow have one neighbor, which is 2222, which is 2222 is Paris. So Moscow already configured, but I have one neighbors, which is Paris. So let's go direct to assign the for the Tokyo, which has 444, 0 and 16. Okay, that's cool. Okay, go direct here, assign. It's 4444. It is what? 0 and 4. Is it like 16? Sorry. It is 16. Okay, the rest are the same. Let's configuration as the same. Okay, now after some time, you see, I paused the video and I completed all the configurations, the OSPF configurations to all other routers. Okay, let's see how all that done. Let's go and maybe do some check on Nairobi routers here. You see, here on Nairobi routers, we have this router ID, and we have 3 networks which are point-to-point, 20, 80, and 16. So go direct and say display current configuration OSPF. Then after that, I see the reference band is it is I mean 100,000 Mbps. The area 0, and we have the network as shown here. So go, let's see the peers, because you see after OSPF being established here, we need to have 3 peers, 444, 666, and 111. So the command is very simple, just display OSPF peer brief. After that, you can see now we have 3 peers which are in full state. We have 6066, we have 4444, and we have 111. Okay. Moreover, let's try to check the OSPF network type by default, which is configured on this one here. So here, what you can see here now, you can just try to say OSPF peer, OSPF interface brief. When you try OSPF interface, display OSPF interface. Yes, when you try to say OSPF interface, it will tell you that the interface is, we have 3 interface. The one interface which is 10, 18, and 22. These are the IP addresses of the Nairobi interface you see here, and the network type is broadcast. So the network type is broadcast. But for this network, which is 5010, the broadcast, and the type of network is broadcast. This router is DR. It's a DR, and the BDR it's .9. So I mean here we have BDR and DR by default. But if the network is point to point, that means we're going to have two router types, which is the DR and the BDR. So if the network is point to point, how can we configure that the OSPF type being point to point? Okay, let's go direct and change one of the network that we said that we need to be a point to point. Okay, go to Dodoma router, it display the peers. Let's go to Dodoma router. And the Dodoma router, you can display OSPF peer brief. So here we see we have only one peer. Oh, this is cool. Why only one peers? Is .5. We don't have .6. .5, we don't have .2. Okay, display current configuration. Current configuration or SPF. You see we have 20 and we have 24. This is the network type. 24 and we have 20. This is cool. Let's go to this side here at Paris. Let's see the configuration on the Paris end. Display current configuration OSPF. So we have also here 4, 12, and no, it's not 20, it's 24. Okay, I think the problem was here. So let's go to OSPF process number 1 and the alias fury. Okay, okay, it's network 0. Now let's undo this one, yeah, because it was configured long here. Okay, copy this one, paste, and then you see it is 24 network. Then okay, after that you can see now go back to Nairobi, I mean to Dodoma router. Now display again the peers. Now we see we have 2 peers, 2222 and 2 and 555. So after that, let's go direct and display OSPF interface. So you see we have 2 interface, 26 and 21, and the network type is broadcast, and this one are the DRs. The DRs because they are 25 and 26, 26 and we have 22. I mean 21, 26, 25 and 22. That's why they are there, because the IP address is large. So it's they have the largest IP addresses. That's why they are DR. You see, because they have the largest IP addresses. That's why they are DR. Okay. Now let's go and set the point to point. This network as a point to point. You know which interface? It's 04. Ethernet 400 and 400 on the Paris. So starting with Dodoma, go to the interface view, go to the interface, which is interface Ethernet 400. After that, you see under this one, you're gonna say OSPF network type, it's point to point. So after that, you see you can now display OSPF network OSPF internet interface. Now, after displaying the OSPF interface, it says that the interface is point to point. But when you check the cost, you see the cost is now 1,000. The cost is now 1,000 between that points, because what we did on the because what we configured on the interface was 100,000 Mbps as the reference bandwidth. So the calculation of this one, it will be the calculation of course just based on the reference bandwidth. So let's see how we see the networks, the OSPF networks here. So that's why we need to configure OSPF, because we've already advertised all the networks on the OSPF domain in the OSPF area 0. That means I'm led now to see the networks which are not directly connected to the router. They have rendered via OSPF protocol. So the cost, it depends to the interface that they have connected. Now you go direct and display the IP routing table, then go filter the protocol OSPF. So after this configuration done, you can see now I'm able to run this network, which is 50, 54, 58, 50, 12, 54 by the protocol, which is called the OSPF. And under this one, you see the cost, it is 1,400, 1,200, 1,100, and 1,200, and 1,000, 300,000, 1,500. Why this one? Why this cost? It's because you see, example, we'll start with 50. 50, where is it located? Is located out here. So it's located right here. So the cost to reach this network, it will be just, or it can be via this route or via this route. The one that is installed to the routing table is the one route that is having the lowest cost. So you see, because this interface, it's Ethernet interface. Basically, the speed of it is 100 megabit per second. So when you take the cost, when you want to find the cost here, you just take the bandwidth difference, which is 100,000 divided by 100 speed, you get 1,000. That's why you see the cost to this network, it's 1,400. That means is it will be 1,000 here, one here, and the other, it will be 1,000 here, but here also it will not take this path because this interface is fast Ethernet. You see, now the route will be just from this point here all the way to this link, this link, this link to this link. That's why you see it is 1,400. 1,000 here plus 100 plus 100 plus 100 plus 100. So it's 400 plus 1,000, which is 1,400. That's the cost. We can go direct and try to ping this interface here from this router here, because you see on the routing table, I see this network. When I need to reach this network, I have to forward traffic via OSPF protocol and via this next hop, which is this next hop. The next hop with this one here. So when I'm trying to forward any packets to this network, my next hop will be Nairobi router, because you see on the routing table it says that the cost to that network is 1,400, and the next hop is 192, 160, 150, 22, and the exit interface, it's Ethernet 4001. So when I'm trying to check this one, you can try to trace it. Just go and trace it. The network 160, it will be just 50.t, right? 2, go direct. Okay, I'm trying to reach that point. Okay, it doesn't give the results. You know why it fails to give the results? Because I've wrote the long address. It's long address. It's supposed to be 60, not 68. Okay, 60. You see, after I wrote 60, the results very fast. You see now the route that was taken by the packets from Dodoma router to this router, which is the Tokyo. It was 22, which is the next hop, which is my next hop because of the cost. I didn't path here. Because the cost here, it's around what? It's around 1,000. It's around 1,000. You see, it's around 1,000. So the direct routes, it will just be this one here. So you see, it's 22, 9, 22 here, 9 here, 5 here, and 14 here, 5, 14, and lastly but not least, it's 2. That's how you can check. So when you display the IP routing table, the general routing table, you see the general routing table, it has a lot to discuss. But few is the network that was learned via OSPF, and there is a network which is directly connected to the router. Example of the network that is directly connected to the router, it's 172.16.100.1. That is network that is connected directly to the router. So whenever the router receives the packet that is destined to this network, the router will direct forward this packet to the next hop, which is 172.16.100.1, which is the IP and which is an interface at IP addresses of Giga Ethernet 000. That's how router forward direct connected routes. That's how we can learn. So you see, this was very cool class. We saw how to configure OSPF in the very cool ways. So after this, let's stop hand here, and then let's meet to the part 4. On the part 4, we're gonna see how we can change this attribute, how we can reroute traffics, how we can find a good way and advertise another networks here. So now it's okay for now. Let's go direct and meet in the next session.